Hello, friends. This is Dave Hurwitz, Executive Editor at ClassicsToday.com, here with Tinnitus Classics, our latest release, and this is beyond exciting. I knew this was coming, but I wasn't quite sure when it would be available because, I just did a long talk on the best Beethoven string quartet cycles, and I couldn't even mention this because there was always the possibility that it wouldn't quite go as planned. But lo and behold, it all worked out. And so now it is my pleasure, a deep, deep, deep honor to present to you the ultimate Beethoven string quartet cycle. And I am not kidding. This is truly the only one you will ever need. It's performed by our very own Quantum Quartette. Now, what is the Quantum Quartette? Well, the Quantum Quartette is your usual collection of major conservatory graduates. This time they come from Curtis. They're Curtis graduates, but they were participating in some recent scientific experiments at Fermilab. Oh yeah, Fermilab, where you have like the cows grazing where the radioactive particles go flying by. So they were at Fermilab, and they were experimenting with the largest possible sized quantum object. And it turns out that of all the possible musical ensembles that you could possibly have, the string quartet is, in fact, a quantum object. Now, why is this? Well, the reason is because in order for an object to be quantum, usually it was thought it had to be very, very tiny. The largest quantum object that scientists have been able to make up until now has been a molecule of about, a couple thousand atoms. That's it. Bigger than that, and the normal relativistic world starts to kick in, and the rules of quantum mechanics no longer apply. And the rule of quantum mechanics that we're really, really thinking about, and that proved this whole thing so revolutionary, this experiment that they were doing at Fermilab, was this. They were trying to demonstrate the validity of Hugh Everett's many worlds hypothesis, which would establish the reality of the multiverse and the fact that there are an infinitude of universes out there in which everything is happening, and everything that ever will happen or did happen or can happen happens. It's out there somewhere, and that includes every possible interpretation of the Beethoven string quartets, including all the ones we know, all the ones that we don't know, all the ones that were Schuppanzig's premieres, all the ones that ever could be. They're all part of the multiverse. The problem is, how do you record a multiverse? Well, it turns out, as I said, that alone of all musical ensembles, the string quartet is a quantum object. What does this mean? It means it's subject to the laws of the quantum universe because it is the only musical ensemble in which the four players are so harmonious in their approach to music making that they actually exist in a state of quantum entanglement. That's what's so amazing about them. It's absolutely, absolutely stunning. They're in a state of superposition with each other. And that's only true of string quartets. Even a solo pianist, he's got two hands. He may change his mind someday about what's going on. Piano trios, well, they're more difficult because they're not usually regularly constituted ensembles. The Beaux-Arts trio may have been a quantum object, but they're gone, so we can't prove it one way or another. Only the string quartet seems to have that balance between, on the one hand, individual personality that characterizes the interpretation in general, but the need for total quantum cooperation in order to realize that mutual goal. So they exist in a state of quantum superposition, and for that reason, string quartets are able to be captured as quantum objects, as in keeping with Hugh Everett's 1957 thesis about many worlds. And because they were able to capture the string quartet as a quantum object, it demonstrated that Everett was right, because the many worlds hypothesis is not by any means accepted in the quantum physical world entirely. There's the Copenhagen interpretation. There's like a whole bunch of different explanations for why quantum mechanics works the way it does. And a lot of people completely dispute the existence of the multiverse and the possibility of all of these different interpretations of Beethoven's string quartets. But no, they are real. They exist. But in order to capture them, certain special conditions have to apply. Happily, one of those is not that the players have to be performing at absolute zero or close to it. In fact, they can perform at room temperature, which is a big plus, believe you me, because absolute zero is not good for string instruments. It really isn't. It does nasty things to the varnish, and all kinds of bad things happen. No, all they need to do is to be completely physically entangled as well as spiritually and multidimensionally entangled, and that's accomplished very simply. It turns out all you need to achieve quantum entanglement of the individual members of the string quartet is, normal bungee cable that you can get at any hardware store. All you need to do is clip all their seats together and poof, they're quantumly entangled. And what's so amazing about it is once they're quantumly entangled and they have the music of each Beethoven string quartet in front of them, they don't even have to play it in order for you to capture it because they already have. That's the beauty of a multiverse. Every possible interpretation has already been done, and all you need to do is record the result. And in order to record the result, you need some rather special computer equipment that I don't really think we need to get into in any detail, but Fermilab has it, and it involves lots of, flashing lights and things like that. Once they're entangled, the performance kind of takes care of itself as long as they have the music of the Beethoven quartets in front of them, one at a time, obviously, and a movement at a time. You have to do it in sections. Otherwise, somehow, they're not quite sure how, the quantum universe knows that it could be, for example, a Mozart string quartet or a Haydn string quartet. You're not going to get Beethoven. That's the thing that's so fascinating about this. How the universe knows it's going to be getting Beethoven just because the music's sitting there on the stand, that the scientists have yet to explain. But the fact is they do. And they capture it all on a several terabyte memory device, which Tinnitus Classics has designed to look just like your average CD jewel case. You can't tell them apart, can you? But this, in fact, contains an infinitude of performances of the complete Beethoven string quartets, including the Grosse Fuge. Let's not forget that one. They're all in here. It's just astonishing. But the question is, how do you get them out? Well, in order to get out any single interpretation of the Beethoven string quartets, you have to take the performances and then you have to decohere them. Decoherence is the key. Now, decoherence is a very technical term, but what it really means is when a quantum property leaks out into the environment, just a bit of it, just one thing. For example, if you're looking at an electron and it's doing its little wavy thing and you want to find out where the electron is and you measure it and you do the measurement, that decoherence effect kicks in and you get a location. You get one location out of the infinite number of locations. So in order to get a performance of a Beethoven string quartet, you need to apply the principle of decoherence to the performances of the Quantum Quartet captured right here on this disc. Now, how do we do that? Well, it's really very simple. This is the easiest part. You have to purchase, I hate to tell you, a decoherencizer. Now, the decoherencizer is a very inexpensive tool. It really is. I have one right here. Let me show it to you. Wait a minute. Here it is. Very, very inexpensive. You can get it $20 on Amazon. This is the decoherencizer, and it allows you to select a performance of the Beethoven string quartets. Now, there is one catch, unfortunately, that the scientists haven't quite worked out yet. When you get the ultimate Beethoven string quartets performed on Tinnitus Classics by the Quantum Quartette, you are not actually getting any specific performance. You're getting all performances. And it's the quantum world. I mean, it's basically random. So you can't determine which performance is going to pop out. It's not like you can get this and say, oh, I want to listen to the Quartetto Italiano or the Yale Quartet, the late quartets, or the Juilliard Quartet. It doesn't work that way. What happens is decoherence kicks in and a performance pops out. And there is no way to know whose performance it actually is. Well, it's the Quantum Quartette's performance, obviously, but it's every performance of the Beethoven quartets that's possible, or ever has been possible. So it may be on period instruments, it may be on electronic instruments. It's going to be the complete Beethoven quartets, but the actual interpretation is always going to be different, but randomly selected. And so the decoherencizer has, first of all, you have two separate compartments, which is extremely handy so that you can get other works as well, by the way. For example, the Haydn quartets, any kind of string quartets, the Janacek quartets, that would be really cool. All you do is you place the disc of the Quantum Quartet doing the complete Beethoven string quartets into the slot, and you push down the lever, and voila, that's it. Now, this actually connects via Bluetooth to your speaker system, and it also contains a very, very large, at least like a terabyte memory chip thing, which will allow you to retain up to, well, let me see, this one, there are different models, but this one, as you can see here, this one has seven settings, so you can keep up to 7 complete interpretations of the Beethoven string quartets at once. And so if you hear one that you like, you can save it. You can actually save it. You can delete the ones you don't like and save the ones you do, which is really very handy. And then when it's done, I guess it's done. When it's done, it just pops up. And, this thing runs, by the way, on dark energy, on the vacuum energy of the universe. But if you have 2 discs in here, that may not be sufficient. So you can always just plug it into a normal wall outlet without any difficulty. And also the vacuum energy of the universe creates a considerable amount of heat. And so if this is too warm when it comes out, you can use one of these CD extraction devices that we already discussed, which are very easy to get. And as you can see, you just grip it and you take it out and you are in business. So there you go. That's how you get every possible interpretation of the Beethoven string quartets. And if it really gets hot, this also comes with a bagel setting right there, which is really quite handy. But anyway, this is a decoherencizer. Who makes this model? Everybody makes them now. Oh, Cuisinart. I mean, it's very, very good. I mean, Cuisinart makes these, physics devices. I think that's just fabulously convenient. So that is how you get your Beethoven string quartets. Now, obviously, because this is not going to be any one specific interpretation, but rather all possible interpretations on this simple little device here. And it comes, by the way, very attractively packaged. I mean, it's not just black and boring. This is only that way because we don't want the heat from the vacuum energy of the universe, causing some sort of fire or something in your home. But because you get those, you really have to be a string quartet nut. I mean, you have to be a serious devotee of the Beethoven string quartets. And you have to be willing to listen to whatever cycle the Quantum Quartette does. I mean, whichever one of their infinite number from the infinite multiverse in which they're performing pops in to the decoherencizer. But if you do that, I guarantee you will have a lifetime of enjoyment listening to the Beethoven string quartets. And you will really be able to determine if, everyone says, well, it's classical, it's infinitely variable, it's infinitely appealing, it has infinite relevance. I mean, we use the word infinity so casually and so shallowly and with such imprecision. But this experiment, which is now available on Tinnitus Classics, proves once and for all that when we said that those Beethoven string quartets were infinite, we weren't kidding. They really, really are. But so far, as I said, this only works for string quartets. And the Quantum Quartet is absolutely the first string quartet of its type ever to give quantum performances of the major works of classical music. And of course, where else to start but with the Beethoven string quartets? So I do hope, this is available everywhere. Any place where finer recordings are sold, you should be able to find the Quantum Quartette. And, oh, by the way, the only thing I need to tell you, though, it's Quantum Quartette, Quartette. Sometimes, because of the nature of the multiverse, sometimes the spelling comes out, American style with one T, sometimes the German style with two T's, sometimes you may see it in kanji, sometimes in Cyrillic, but it's all the Quantum Quartette. The more languages you know, the easier it will be for you to determine that, of course. It's always the Quantum Quartette, and these are every conceivable performance of the Beethoven string quartets in all of their infinitude. So keep on listening, folks. If you get this, please write in. Let me know what you think. Share the performances that you really like with your friends. You own them. It's only $9.95 for the entire set. $9.95 for all of the performances of the Beethoven string quartets that could ever possibly exist in the quantum universe. I think that's one hell of a bargain, don't you? Thank you for joining me. Take care.